temperature change, and heat capacity. So essentially what we're talking about here are the energetics of temperature change. So imagine that we had a boiling pot of water. So you have this on the stove, we have some boiling water in here. So let's go ahead and say boiling H2O. And you're heating this on your stove, you have a gas stove here, there's your flame. And then suppose you put 2 spoons in it. So 1 spoon, let's go ahead and say this one's made out of aluminum. And the other spoon is made out of wood. And suppose you let it sit there for, say, 10 minutes, and you came back to go stir your pot. Which spoon should be the one that you grab? Why? Yeah, so you want to grab the wood spoon because you might burn yourself if you grab the aluminum spoon, right? So what that means is that the wood takes more energy to heat up than the aluminum does. So we can say that wood takes more Q to heat up. So what we can say then is that wood has a higher heat capacity than aluminum does, or higher specific heat. And just to be consistent with your book, I'm going to use specific heat here. I'm using these words so interchangeably because I tend to use them really interchangeably. So once again, here is the amount of heat, or Q, required to raise the temperature by 1 degree C. All right, if we're working in metric, the units here are joules per gram degree C. The joules here, J, is a heat term. So J is for joules, and it is a heat term. You guys know the English equivalent unit for a heat unit here? What do we typically use? This is the calorie, yes. And we're going to be convert back and forth between the two. But before I do that, I want to go ahead and take a look at a little table that I drew up. Most of these were actually taken from your textbook, so you have a little table in there. A few of them I grabbed off the internet just to make a few points here. All right. I typically don't like for you guys to memorize table values, but there's one table value here that'll be very beneficial to remember, and that's the specific heat of water. That's actually the conversion factor to go from joules to calorie. So it turns out that we have a conversion factor here of 4.184 joules is equal to 1 calorie. Notice the way I wrote the word calorie, I used a lowercase c on the word calorie. It does make a difference if it's lowercase or capital. So where do we see the word calorie in our daily lives? Probably when you're looking at nutrition facts on like the back of a candy bar or something. And we call that a food calorie. And it turns out that a food calorie is equal to 1 kilocal. Or we can say it's 1,000 calories. Or we can say it's 1 capital C calorie. I'm not quite sure why we made this distinction here. My theory, it was a way to make, for the manufacturers to make soda pop look less fattening. Because the numbers end up being smaller by an order of magnitude of 3. So they end up being a little bit smaller. And it also turns out that most of the systems that we're looking at, on the macro scale of our bodies and whatnot, are in the order of kilocalories. So that could be another reason why they do that. All right, so imagine that you're walking outside on a hot summer day. You're to your back porch. The sun's shining on it. It's 100 degrees outside. You're barefoot, and you have an option to walk on a wood surface or a concrete surface, and you're barefoot. Which one would you rather walk on? Probably the wood one. Like, you guys just conceptually know this, that it's going to be cooler, right? Well, let's take a look at it in terms of the heat capacity. So here, concrete has a much lower heat capacity, and then wood has a higher heat capacity. So it's probably still going to feel hot, but it probably won't give you second-degree burns at the bottom of your feet, right? So you have objects of different heat capacity. The ones that have a low heat capacity heat up fast. Ones that have a high heat capacity heat up slower. All right. There is a way to express this in an equation. So the equation for this is Q is equal to MC delta T. Is the overall equation. Definitely something that you're probably going to want to commit to memory or just throw it on your note card, right? But if you do enough practice, you should memorize this. All right, what the units are, and we already defined what Q is, right? Q is the amount of heat transfer and then C is your specific heat. And recall what the units are. The units for this are typically in joules per gram degree C. Just make sure that if you're using a table that's not from our textbook, that these are the units. Sometimes I've seen some tables published in calories per gram per degree C. I've even seen one that was fully Englishified in calories per pound per Fahrenheit. So it's not very common to see it that way. People just like to use this one. All right, and we used the M one before in a previous calculation, didn't we? What do you think that means? That is the mass. And that is the mass of whatever your system is. So it's the mass of the water, it's the mass of the aluminum block, it's the mass of the wooden spoon, etc. All right, delta T is your temperature change. That is how much it changed by. So based off of the units for specific heat, what do you think the unit should be on the temperature change? It should probably be in degrees C. And I do want to point out, because we're looking at a change in temperature, you can use degrees C or Kelvin, because the amount of range the Kelvin scale goes across in any change is the same whether it's Celsius or Kelvin. Is not the same for Fahrenheit because we have that factor of 9/5. So just be careful of that. I do have a question on the practice quiz from last semester where I gave the units in degree F. You have to convert to Fahrenheit, from Fahrenheit to Celsius first. All right, so what I plan on doing for the remainder of the class is to go ahead and work on some practice problems. Oh, back up a second here. What is temperature change? We typically change is defined as final minus initial. So we're going to go ahead and say it's T final, or TF, minus TI. So it's final minus initial. And if in any of your classes, if you have this delta sign for change, it's always that way. It's final minus initial. You guys will even see that when you guys start doing your calculus problems. You do the difference, and it's final minus initial.